Welcome to Algebra 2 Regents Review. This is Due Now with Miss Kempton. Thank you for coming. All right, let's get to it. Number 1, the expression is equivalent to. So we can do this two ways. Way number 1 is our little shortcut method. Whenever you see equivalent, we can store in a number. So I'm going to store into my calculator 2.15. I want to avoid numbers like 0, 1, 2, 3 even. So I'm going to go ahead and use 2.15. And for y, I'm going to just use 3.15. Completely random numbers. So let's get to it. 2.15. Stow is on the left bottom. 3.15 stow, and then you're going to use your alpha key. All right. So we have a root 4. So that is on the left. You're going to go to math, and you'll see either option 4 or option 5. So if you press option 4, you'll see root 3. You can always just go back and change that to a 4 if you want. I have 81x to the 8th power. Whoops, not. Okay, and then I have y, so I'm going to do alpha y to the 6th power. Okay, so this number is just what I'm looking for, what's equivalent to that. So option 1 is 3x squared y to the 3 over 2 power. So what you notice is that these are equivalent to each other. I would definitely try all options. I'm telling you now that I did, and choice 1 is the correct option. I'm just trying to save us some time. Now I will just go through this briefly with you the long way. So for this question, we're going to be working with a base that's underneath a radical. So whenever you see an exponent and a root, this is going to change so that your base has a fraction as the exponent, and the exponent goes on top and the root goes on the bottom. Now what I like to tell my students is that if you are at the top of the list, you get to go inside the party, but if you are at the bottom of the list, you have to hang out outside the party. So what we're going to do is we're going to take that 81, and 81 actually does have a secret exponent of 1. So I'm going to put the 1 at the top because that was inside the party, and I'm going to put the 4 at the bottom. I'm going to change this to x to the 8 over 4 power and y to the 6 over 4 power. So 81 to the 1/4, you can just throw that into the calculator if you need to. That's the 4th root of 81, which is 3. 8 over 4, that just simplifies to 2. And 6 over 4, if we just divide each of those by 2, we get 3 over 2, which was option 1. All right, moving forward. After Roger's surgery, his doctor administered pain medication in the following amounts of milligrams over 4 days. How can this sequence be modeled recursively? All right, this is the key word here. Recursively, I like to think of as two things, like Dr. Seuss, thing 1 and thing 2. You have to have thing 1. So what do I mean by thing 1? They have to give you a first term. Okay, so there should be two things. They have to give you the first term, and then they have to give you a second formula. So that being said, I can automatically cross off option 2 and option 4 because they don't have two things. So from there, I'll notice that my first term is 2,000, so that makes sense. But now I need to decide, how am I getting to 1680 to 1411.2 to 1185.4? So if I look carefully, this right here, don't get scared by this. This just represents the previous term. So in this case, our previous term would be 2,000. And then what are we doing after that? Well, for this one, we're subtracting 320. For this one, because it's right next to it, we are multiplying. So let's check out what happens if I take 2,000 and I subtract 320. All right, so 2,000 minus 320. Okay, that was my next term. But what happens when I subtract it again? Hey, I don't get the next number. which was 1411.2. So what happens if I try option 3, which was multiplying it by 0.84? Let's see. 2000 times 0.84. Hey, I get 1680. Let's try again. Hey, that's my third term. If I try it one more time, that is my fourth term. So therefore, this is the correct answer. All right, and our last problem here, for which values of x rounded to the nearest hundredth will, and I have a little equation here. Now, because there's an equal sign, okay, and I just want to find the values of x, I can actually go ahead and plug each side into my y equals. And actually, a lot of times for Algebra 2, that's exactly what they want us to do. So if you ever see something that looks like this, where they set the two equal to each other, they only want the x, okay? So I'm going to go ahead and graph these to see what's going on. Now I'm going to give you a little bit of calculator advice here. The absolute value, you're going to press math, num, and there it is. You're going to see the abs. Now for the log button, it's going to be math, alpha, math. So once I plug each of those in, it's going to be a little bit easier for me because I have a graphing app, but on the TI-84, here are the buttons that you're going to push, okay? You're going to press second trace. When you get there, you're going to see the intersect or intersection, and then you're going to move your tabs to the left or to the right to where they intersect, and then you're going to press enter 3 times. I know that's a lot of information, so you might have to take a screenshot of that or take a picture of it. So let's go ahead and see what we got here. I'm going to plug these into the y, so I'm going to go to math, num, abs. So there is my x squared minus 9. I'm going to get out of that minus 3. That's the left side of the equation. Math, alpha, math will give me a base of 3. There's my x. So when I press graph, like I said, it's a little bit easier for me. I could see right away, and all I have to do is push it. But I notice in that upper left, I see 2.29. That is one of my intersections, my only x, remember. And then over here, it's going to be 3.63. Now, if you also look, where is, no, I don't have that. Forget that. Okay. So our answer is then choice 1. That is all. Thank you for following.